Hello everyone. This video, we are going to finish the first part of centroid. Okay, because this semester we'll talk about centroid many times, so this is the first time. Okay, and in the previous we used the centroid area formula to prove you the centroid position of right triangle. I say the centroid position of right triangle is B over 3, H over 3. Okay, and then we will use this to, okay, we'll use this conclusion to calculate, okay, the centroid of composite bodies. Okay, because in most of time, the shape we face in the mechanics in the material, it's not not everything is rectangular or every shape is rectangular, every shape is right triangle. Sometimes is very for this is an example I will show. Yeah, looks like it's not a shape. It's difficult to recognize this as a rectangular or right triangle. Okay, but we still can analyze. We still can calculate the centroid of these composite bodies. We can make some tricks, do some magic. We still can calculate the centroid of composite bodies. So how to do that? Okay, because this technique we also use a lot in this semester. So I have to show this to you. Okay, so here's the strategy in the textbook. It say, okay, if we have composite bodies or some very strange shape of bodies or very strange shape of area. So first of all, could you so try to divide this area or the body into a simpler shape? Okay, dividing the body or object into a finite number of composite parts that have simpler shapes. Okay, divide it. So you have to divide it by yourself and then divide it into your simpler shapes. Okay, what is simpler shape? Okay, rectangular is a simpler shape, and right triangle is a simpler shape. Okay. Okay, that's we use very often in this course. Rectangular and right triangle, and rectangular and right triangle is a simplest shape. Okay, just the first step, just divide your composite area, composite body into a simpler shapes. Okay, and then here is another thing. It say if your shape has a hole, your body has a hole, or it will become a negative weight or negative size. Okay, hole is a negative weight or negative size. But I think in this class, I won't let you calculate negatives, the whole stuff, because that will make that will make calculation more difficult. So, okay, but this is the strategy is there. So the strategy is there. If your shape has a hole, just treat it in a negative weight or negative size. Okay. Okay, the third one is establish a coordinate axis and determine the coordinate of center of gravity of each part. Okay, so simply speak, determine the coordinate of center of gravity or centroid of each part of each part. So first of all, you divide your composite area or composite body in a simpler shape, right? You divide it into a many simpler shape, and then try to identify the centroid of each part. Okay, okay, I should make this identify the centroid in each part. I think that's more clear. Okay, that's much easier to understand. Identify the centroid of each part. Okay, first of all, you divide your shape in many simpler shape, many parts. Okay, simpler shapes, many parts. Okay, and determine the centroid of each simpler part. Okay, okay, I would say each simple part. Okay, and then identify the centroid of each simple part. Okay, and then doing the summation. And the summation here, the textbook say use the centroid equation. Okay, the centroid equation is this integration, but actually when the practice, we will use back to the summation format. Okay, we're back to user dimension mode format. The x component of centroid is x coordinate times x coordinate of x coordinate of each centroid and times each area and divided by total area. And the y component is y component of each simple area and then times its area and divided by total area. Okay, but I think right now you don't understand what it looks like in this formula. So I have to show you the example to show what this formula means. Okay, because right now it looks very abstract. Okay, so we'll start example 6.4. Okay, locate the centroid of this blue area. Okay, so let's start with this. Okay, so first of all, this is a very complicated shape. Okay, so remember when you face a complicated shape, okay, first I'll divide your shape into a simpler part or simpler shape. Okay, so for this problem, what I can do is, okay, I can divide like this. I can divide something like this. Okay, and then it will become a simple part. Okay, so I have one. Okay, I would say this is one. I call this one. I call this two. And I call this three. Okay, the one is a rectangular, two is rectangular, and three is the right triangle, right? So I divided a complicated shape into a simpler part or simpler shape. Okay, that's the meaning of this the first strategy. Okay, divide the body object into a finite number of composite parts that have simpler shape. Okay, I divide this complicated shape in three parts, and each part is a simple shape: rectangular, and right triangle. And the next thing, okay, there is no hole, so just ignore the second strategy. So let's jump to the third strategy. Okay, the third strategy that I just say, identify the centroid of each simpler part. Okay, so okay, what's the centroid of one? What's the centroid of one? Okay, what's the centroid of one? One x bar, y bar. What's the centroid of one? Okay, the centroid of one here is a rectangular shape. Okay, rectangular shape. Okay, so its centroid should be like here. Okay, so what's the position x coordinate of this is centroid? X coordinate of the centroid. So it's -2. So this must be 0.5 here. This must be 0.5. So x bar is -2.5. Yeah, because this system this problem it already give you the coordinate, x coordinate, y coordinate. Origin is here. Okay, so the area one, okay, the centroid of area one, x component is -2.5. So what's the y centroid of y component of the centroid of area 1? So this will be 0.5, right? So okay, you divide into simpler shape and determine the centroid of each simpler shape. Okay, so okay, that's area 1. So what's the area to centroid by area 2? The central area 2, I think it must be here because the rectangular must be at the center. So here, I think here is 1. Here is 1. So it's -1. Okay. And what about the y component of the centroid of area 2? So here, I think, okay, be careful that the total height here is 3. So the centroid here, okay, so it must be here, must be 1.5, right? So 1.5, okay? And area of 3, okay, area of 3 is right triangle. Okay, we just say, what's the centroid of a right triangle? I think the centroid of right triangle is here, okay? And this must be 3 over, 3 over 3. Okay, and this is must be 3/3. Okay, remember the formula. Okay, go back to the previous line. Okay. Sorry. I should hide this first. What's the centroid of right triangle? Okay, it's here. X component is b/3. B over here is b/3, and here is h/3. Okay, here x here is b/3, and y here is h/3. Okay, so when you go back to this shape, okay, we'll go back this shape. Maybe okay, I draw a new one. Maybe it's not really clear. Okay, let's focus on the right triangle here. Right triangle is 3. Okay, maybe it's not in scale. But sorry. That's right angle, right triangle 3. Okay, that's right triangle 3. Okay, then here it says 3. What's the height? 2 plus 1 is 3. So the centroid of this right triangle is here. Here. Okay, this is 3/3. And what's here? Okay, it's also 3/3. Okay, just convince yourself. Okay, the centroid of right triangle. That's why in previous video I say the conclusion for the centroid of the right triangle is very important. You will use this a lot. Okay, so here, I think it's here. It's 1 1. Okay, it's very simple. It's 1 1. So it's 1 1. Okay, so we have identified the centroid of each simple object, and then doing the summation. And then summation, if we have to use the discrete formula, okay, so x bar, okay, finally x bar is equal to, I think it should be I. Okay, it's summation x is summation x summation xi ai, then summation ai, and y bar is summation x. So sorry, it's yi summation yi ai divided summation ai. Okay, that's formula for the summation. Yes, you go back to discrete again. Okay, that's why discrete is used a lot. Okay, discrete formula used a lot. Okay, so let's calculate x bar. Okay, so and then we also need the area of each area of each simple shape. Okay, so what's the area? 1. It's 1 times 1 is equal to 1. Okay, what's about the area 2? Is 2 times 3, or 2 times 3 is equal to 6. And okay, so it should be a bar. It should be a bar. I think I should add the bar here. Okay, so and the final one, area 3, is 3 times 3 divided by 2. Okay, it's 4.5, and then we have all the information. So what's the final centroid position of this composite area? So it's very simple. So it's area, the denominator, the numerator, and denominator just the sum of the area plus 4.5. And okay, x is minus 2.5 times 1 plus minus 0.1 times 6 plus 1 times 4.5. Okay, so just the x component of x centroid x component of each centroid, x component of each centroid, and then times its area. Okay, that's a summation xi bar ai. Summation xi bar ai. So minus 0.5 times 1, minus 1 times 6, 1 times 4.5. And I think if this formula is right, okay, if I write this correctly, what's the answer? Let me check if I write this correctly. Yes, correctly. Okay, so this after calculation, it should be minus 0.348. Okay, same thing. It's the centroid, the centroid position in y coordinate. Okay, okay. The denominator is also the same. Okay, it's just the sum of area. Okay, and the numerator is just the y bar times each area. So it's 0.5 times 1 plus 1.5 times 6 plus 1 times 4.5. And let me check if this is correct. 105. 1.56, 4.51. Yeah, it's correct. So after all, you will get your y bar is 1.217 and units millimeter. Sorry, meter. Okay, so that's the how you calculate the centroid of composite bodies or composite areas. Okay, first of all, you divided your complicated shape into a simpler shape because for example, in this example, I divided this shape into one rectangular, this rectangular, second rectangular, and one right triangle. Okay, and then you have to identify the centroid of each simpler shape. Okay, and for the rectangular shape, I think it's very easy to identify the centroid. Okay, and for the right triangle, just you have to memorize the conclusion we just showed in the previous video. Okay, the centroid of the centroid of the right triangle is base over 3 here, base over 3 here, and height over 3 here. So you have to remember that. Okay, and then after you identify the position, the centroid position of each area, and then calculate the area of each simple shape, and then use the summation formula for the centroid, and then you can determine the centroid of each centroid of the composite area. Because this technique is used a lot, especially in later we'll calculate something called neutral axis. When you're trying to when you try to calculate the neutral axis, actually you also use the same procedure. Okay, use the same procedure to calculate neutral axis. It's the same as you calculate the centroid of composite body. The same procedure. Okay, but that's neutral axis is for later. Okay, for later. Okay, for later in the later of this course. Okay, so I have to introduce this to you because this really used a lot in these courses. Okay. Okay, so that's the calculation of the centroid of composite bodies. Hope you can understand this concept. You need to practice in your free your ordinary time. Okay, you need to practice. Okay, okay. So I just start the video here and see you in another video. Bye bye.